Ladies and gentlemen, for this session, I am so thrilled to invite and welcome a gentleman up on stage, and I'm hoping that now, since we've settled in a little bit, your enthusiasm is going to rev up a little, and let's move it on to the third gear as we move on to this session that's going to now take center stage. Also, during the course, you've clicked a lot of pictures. We've been seeing you click selfies and some videos and pictures. Please upload them on LinkedIn, on your choice of social media. Tag us, use the hashtag so that we also can, see all of these wonderful captures that you're clicking. It's going to be nice to see it on social media as a memory of you joining us at the 9th edition. With that, let me take this opportunity to hand over the stage. As I do this, please join me in welcoming him up on stage, Mr. Tadashi Kasahara, General Manager, Advanced Robotics and Digitalization Business Unit, MAKINO Asia Limited. Ladies and gentlemen, please.
Okay. So thank you very much for introduction. I'm Tadashi Kasahara from MAKINO Asia company. I worked in R&D and also in charge of the automation and the digitalization. So thank you very much for having a time today. And the next 20 minutes, I'd like to show you about the automation product and innovative technology and also machines for die and mold. So this presentation consists of the 3 chapters. The first one is the introduction of the MAKINO and automation history. And the second one is what are the important things for automation for die and mold. The third one is high performance machines. So I'd like to show the latest product. So let me show you the MAKINO product. In die and mold market, so we have a V series and F series vertical machine center is very, very popular. And next is the automotive parts machining area, the horizontal machining center A1NX series, and the vertical machining center PS series is very used. And the aerospace market, so we have a aluminum wing rib machining center, large A series, and titanium machining center, we have a T series. It is for the jet engine housing and landing gears elements. And the last one is EDM machines. So we have a Shinka EDM, so Edge series or EDAF series, and wire cut EDM machines also. In addition to the machines, so we have FF cam systems and also automated systems. So I will explain that later. And in domestic Japanese market, we have AMR systems. So I assist is material handling and tools handling. So let me show about the history of the automation. We started fries machines and 1968. So the horizontal machine center and put on the auto tool changers and the CNC controllers. So this is the start of the automation. It is a very big impact for the market. And the automation history, so 1972, transfer machines, multiple machine centers are installed into the automotive company. And in 1984, the flexible manufacturing systems installed our own factories. Now there are a lot of the kind of the automation systems. For example, the robot system or control system. So exists. So I will show you the 3 current systems for the automation. The first one is a module MMC2 system. It's a pallet handling system. So it is very suitable for high mix, low volume parts machining. For 5,000 to 50,000 parts per year is very common. And also a robot linear style system is very, very flexible. and robot moving inside of the systems and approach to the variety of the machines. It is very common for the die and mold automation because die and mold process, there are a lot of the type of the machine, milling and electrode milling and EDM machines and CMM also. So the robot system is very flexible. It is very common system. The last one, it is an entry model for the automation system. The microcell BAT, you can see the center of this figure. It's a very compact stocker system. So 50 pallets or 132 electrode is stocking on the magazines. This is a unique point, is the both right side and left side approach. So this figure is a milling and also EDM machines. But we can choose two EDM machines joined to the BAT system. Please see this video. This is a demonstration video. It is for the mold machine and combined EDM machines. The first thing is EDM CAM system operating. And this system is combined to the CAM system, and a lot of data is coming from the CAM system. And this system can manage and schedule each pallet, each electrode, each mold parts. So this is have a very good, very easy to understand UI display. Now is preparing the mold, and this unique point is a RFID system. So RFID is reading each pallet so that there are no long process and long NC program execution. Now is starting the milling side. Automatically the measurement start and cutting also started. And this example is electrode machining is outside. So if we finish the electrode machining, so operator can move this electrode to the BAT systems. The put into the BAT systems, so also RFID system can read everything of the electrode. And this is connected to the EDM side and the measurement of the position and rotating. So after finishing the milling, and this milling insert is put into the EDM machine automatically. And measuring the position, and also electrode side is automated exchange and starting the EDM process. So this is an example of the automation cost saving. This is one of the example. In this case, two standalone EDM machines, so but three operators, so availability is 66%. In this case, so change to the automated. One operator can handle the two EDM machines, and the availability is reached to the 90%. So in this case, investment payback period is less than 2 years. So for example, the 1.5 or 1.8 years. The next chapter is automation error for the die and mold. You know that OEE productivity indicator is very important. So overall equipment effectiveness. If this value is 100%, then your system is fully automated, no downtime, and as fast as possible, and no defect parts output. But this OEE is calculated by this formula. The availability and multiple the quality and also performance. So we can improve the availability using the material handling. It's called the automation. But it is most important thing the quality and the performance. It is a machine side. So for die and mold market is a very strict accuracy and surface finishing, so that these two quality process and standardization and the high performance machines are necessary for the automation. So this is one of the key process of the quality. So this is one of the insert into the main mold. But the insert is created by the small 5-axis machine. But the cavity side, the mold side is a very big machine. But the smooth insert necessary to 3-axis, 5-axis, and small and large machine, everything should be same accuracy necessary. It is the most important thing. I'd like to show some technologies. The first one is a GI control. It is for 2D or 3D curved surface finishing and shorter than the machining time. So this is a result of the GI smoothing function. You can see the red, green figure is a little bit scratch, you can see. But the smoothing function executed to change to the blue one, there are no scratch. This is a MAKINO unique technology. The MAKINO, the inside of the CNC, the direction of the feed rate, smoothing, and also adjustment, the path also smoothing. And these two functionality combined into the one controller. And the next unique technology is the E-stabilizer system. The temperature sensors inside into the column and the bed and predict the thermal deviation during the machining. So you can understand the temperature of the factory is a little bit change from the morning to the evening. In this case, so almost all machines a little bit inclined happened. But the inside of the temperature sensor is predict the thermal deviation and compensate automatically. So this technology is very common in machining tool centers, but MAKINO's unique technology is optimizing this in your factory. You understand, so the temperature distribution is a little bit different each customer's factory and between the MAKINO's factory and also customer's factory. So this is a limitation of the accuracy. But MAKINO technology is optimized in your factory about a compensation system. So this is a very easy to use. So following the guidance screen, machine operator put on the ring gauge or artifact onto the machine table and start of the measurement of this position. So in each 5 minutes or 10 minutes. During this motion, so inside of the CNC is gathering the temperature of each position and analyze the relationship between the deviation and the temperatures. And also, so optimize the new parameter is coming from the inside of the CNC. This functionality is a very good result. This is a V100S, is a very big machine. Height is 4 meters, width is 5 meters, depth is 6 meters. 48 hours execution of the machining, and the temperature is changed 6 degrees. But deviation of the XYZ direction is 15 micron, the less than 15 micron, plus minus 8 micron. The last chapter is high performance machines. I will show you. So V33i and V56i is a good performance for the die and mold machine. So this is a multi-cavity rubber mold that over 200 cavities and 65 hours finishing cycle time. But The maximum error is within the 3 microns. And also, this is a IQ series is a linear motor machine, a very precise machine. So this is a step of the 0.3 micron figure. But you can see this blue line, so you can understand that 0.1 microns, so the steps IQ can do that. And this is a successor of the V33i machines. So this machine, you can see the white line is a Z backlash point. The quadrant switching is happened in white line. But latest compensation system is there are no scratch inside of the in the quadrant switching positions. So this is the high speed of the V300 machines. So you can see the color map. The left side is a V33i. The blue area is a commanded feed rate if 2,000 millimeter per minute. But you can see the red area is reducing the feed rate to 800. It maintains the accuracy so that automatically speed down in the V33i. But you can see V300 is there a small red area so that 10% shorten the cycle time is achieved. So this is F6 machines. The roughness is 0.2 micron and accuracy is 10 micron. It is very good for the plastic mold or die parts. And it is also can do that automation system. So this is the last page. So MAKINO can provide a one-stop service for the automation, not only automated or material handling. So we can provide a quality process and also a high performance machines. So MAKINO contribute a high accurate die and mold, a fully automated system. Thank you very much.
Thank you so much, sir, for taking us through that presentation and for sharing your wonderful insights. May I please request you to join us center stage? May I please request our Mr. Sherigar to join us for giving away a token of appreciation to sir. Ladies and gentlemen, would you join us in thanking him for his time and for also being here as one of the presenters for the technical session?